About 3 million years ago, the volcanoes of Western Victoria spilled their lava across these ancient plains. And before that was the sea. 16 million years ago, it covered what is now the Moorabool Valley at Batesford, 10 kilometres northwest of Geelong. And its creatures left their shells and bones on its watery floor. So the basalt hid a gigantic deposit of limestone, together with some clay and silt. Adjacent to the dog rocks, these were formerly an island. In the era of Craig's great-great-grandfather, Peter McCann, one of the founders of what is now Australian Portland Cement Limited, helped to discover this buried limestone treasure. The foundations for a great industry had been laid. Today, it has developed into a most significant company in Australia's building industry, the Geelong operations of a vast complex, bringing together the raw materials of the rich valley, plus Australia's fossilised energy, to make Geelong Portland Cement. Portland Cement, developed in England over 150 years ago, was so named because it resembled the building stone found near Portland in southern England. It is this product which, perhaps more than any other, has, in less than 200 years, been the means of bringing Australia to the gateway of the 21st century, changing a pioneering continent into the great southland of our hemisphere, the world Craig will live in during the opening decades of the 21st century. Geelong, a thriving, highly industrialised city of 130,000 people, on the shores of Corio Bay, 67 kilometres southwest of Melbourne, is intimately related to the history of APCL, which began at Fyensford in 1890. Nearly all the materials needed for Portland cement manufacture come from the Batesford limestone quarry nearby. Years before the quarry faces opened up, the company's scientists have been feeling beneath the overburden with test bores to discover the composition of the limestone. Its chemical makeup varies, and the quarryman's craft includes knowing where to dig. When the time comes, the basalt overburden is shifted, holes are drilled, the limestone is blasted and begins its journey.
Mobile 8, is everything okay there? Give us a 10-second countdown, please, before blast. Over.
On the quarry floor, a hammer mill reduces the newly won limestone from boulder size to cricket ball size. The first pre-blending of material from various parts of the quarry takes place here. This hard-won mixture of limestone and clay is conveyed 4 kilometres, finally being deposited on these man-made mountains which often contain up to 150,000 tonnes. The limestone is deposited in 2 different grades, ready for further blending. Beneath this stockpile, a double belt system fed by reclaim ploughs conveys limestone to the mixing and grinding complex. Producing cement is a bit like baking a cake. The ingredients are limestone, clay, and a little bauxite, iron scale, plus water, and later a little gypsum. Get the recipe right, mix them to target quality, cook them at high temperature, and you've got a good one. Only the pots and pans at APCL are bigger, much bigger. Within this 7-storey high complex, graded limestone is received and smaller quantities of bauxite and iron scale are stored. They are deposited on a conveyor in proportions controlled by a computer. And then fed into a mixing and grinding mill powered by 2,600 kilowatt motors, enough electricity to light up 2,000 houses. The basic ingredients are thoroughly ground with water, and the resultant mix is pumped into a cascade blending system where great bubbles of air agitate and mix them thoroughly. Finally, by gravity, the mixture is drawn down from the silos into holding basins. It's called slurry, a most marvellous mixture. The mix, the final blend of compounds, which combine chemically and physically to make cement eventually, is about ready for cooking, and the stirrers must be kept going until it's wanted for the oven. The ovens, they're called kilns, are massive, up to 170 metres long and nearly 1,000 tonnes in weight. Tilted at a 2-degree angle, they rotate once per minute. The slurry dries and heats as it progresses down the kiln towards the flame, swirling into the lower end. About halfway down the kiln, at a temperature of about 900 degrees Celsius, limestone calcium carbonate decomposes, losing its carbon dioxide content. As the mix gets towards the end of its journey through the kiln at 1,450 degrees Celsius, the oxides of calcium, silicon, iron and aluminium combine to form clinker. The gases from the process are drawn through the kiln, gathering some dust from the mix. To protect the environment and prevent pollution of the atmosphere, the gas stream is directed through these huge electrostatic precipitators, which trap the dust particles. A new mixture called clinker cascades from the kiln's fiery mouth. At the moment, it doesn't look much like cement, but in clinker form, these white-hot pebbles, that's what it is. Fans blow massive amounts of air through the hot clinker bed to cool it. Some of the heat poured from the clinker cooler is returned to the kiln to provide part of the energy needed to produce more clinker. Dusty air from the cooler is taken to gravel bed filters to remove the dust, and the cooled clinker is stored ready for the final stage. Gypsum, a form of calcium sulfate, is added just before the clinker is fed into large ball mills. Here, chrome steel balls like these progressively pulverize the clinker in 2-compartment grinding mills. And finally, the product has become this marvellous binding material, Portland cement. Now it's ready to be conveyed to the dispatch complex, high on a hill overlooking the Moorabool and Barwon rivers. But the people at APCL have been making quality control checks at many stages before it got this far. On the quarry floor, in the preliminary grinding mill, where a computerized system manages the mixing. In this X-ray apparatus, where the elements used in cement manufacture are tested at several stages for calcium, silicon, iron, aluminium content and trace elements. In the laboratory, where its physical properties in mortar and concrete are measured. And there are many more skills too. In the quarry, where limestone is extracted with carefully measured charges. In the maintenance workshops, where skilled tradesmen maintain and modify the extensive equipment. Draftsmen who supply detail for plant updating. Electricians who maintain literally thousands of electric motors and untold kilometers of wiring. Engineers who monitor the huge pumps. The techniques of kiln management contribute to yet another aspect of target quality and fuel economy. This is important too, since fuel usage represents a large part of the cost of cement manufacture. People and machines who manage and operate an investment worth tens of millions of dollars and those who look after visitors and callers. Safety and occupational health feature prominently in all aspects of production and maintenance. Here is the Occupational Health and Safety Committee, which meets regularly. APCL's origins go back to 1888, when Geelong pioneer, stonemason Peter McCann, purchased this limestone-bearing land at Batesford and founded a cement plant at Fyansford. By 1911, production had reached 20,000 tonnes a year, and the cement industry had become an integral part of Geelong's economy. Now, 350 people are employed at the Geelong complex with an annual wages bill of $13 million. The product contributes substantially to the Australian economy, and APCL has shaped significantly both the history of Geelong and the development of the Australian cement industry. Today, this plant can produce over 750,000 tonnes of cement a year and is one of the bulwarks of Victoria's prosperity. The Geelong Works, one of Australia's biggest, is the largest of three owned by APCL, which since 1974 has been owned by two major Australian companies, CSR Limited and Pioneer Concrete Services Limited. APCL's product starts its journey to the marketplace here at the dispatch department. Most of these are bound for the company's North Melbourne and country depots, and the bulk cement will be sold to many hundreds of customers. The APCL name is also carried along the highways to bulk users throughout the state. The company makes sure they look their best. Twenty 20% of APCL cement is bagged in a 5-storey bagging plant under a label which has become an old friend. Mixed with sand and water, it becomes mortar. Mixed with aggregate, sand and water, it is concrete, which combined with steel enables man's buildings to reach even higher peaks of beauty and function. Concrete is the symbol of Australia's new age. Almost everything that is built with concrete, much of it with cement from Australian Portland Cement Limited, Geelong. The other 80% of cement goes in bulk to large-scale operations, whose products have transformed the society we live in. No two segments of the Westgate Freeway overpass in South Melbourne are the same. It's a highly specialised project, and the concrete is mixed in a unique pan mixer. Concrete is manufactured for precast panels, which are made on-site at the Redwood Gardens estate near Moorabbin Airport in Melbourne. The entire project is made of tilt-up construction. Each concrete panel has a high cement content, frequently 400 to 500 kilograms per cubic metre. High-strength concrete was used in the construction of Melbourne's Hyatt Hotel. Every single room has interior walls of reinforced concrete. The concrete used in both the Melbourne Hyatt and the Rialto buildings featured a high content of cement, enabling speedier construction. Geelong cement supplied to Pioneer Concrete is being used for the Riverside Quay at South Melbourne in a 5-year construction plan. But the world was made for people, and it is people who are at the heart of the APCL enterprise. Up here, overlooking the famous river valleys of Geelong, company people can enjoy the peaceful life, relaxation from the vigorous activity that goes on 24 hours a day, 365 days a year down there. The company also supports many community activities: football, scouting, care of the aged, student scholarships, United Way, Shannon Park. And what of Craig's World? APCL have been overcoming the dust emissions, which were an environmental problem. Electrostatic precipitators, gravel bed filters and fabric filters control air pollution. Wastewater is monitored and looked after. A tremendous amount of planning and energy go into removing limestone from the quarry and turning it into cement. Equally, millions of tons of overburden, removed to uncover the riches of the ancient sea, are stored for the day when the landscape is rehabilitated. At the end of the 21st century, there may be a large lake like this, where presently there's a limestone quarry. You see, these paddocks were once a quarry. In the future, when more cities have pointed their fingers at the sky, when more roads and bridges span our continent on threads of mortar and concrete made with Geelong cement, Craig's World will be beautiful and whole. Different, but better than it was.